All right, we're back. I'm going to finish up section 6.2 today, talking about linear transformations of random variables. So if y is a plus bx is a linear transformation of the random variable x. Okay, so we're going to linear transformation. All right, what are we going to do? Well, the probability distribution has the same shape as the original probability distribution if b is bigger than 0. The mean of u is going to be a plus b times the mean of x, okay? And then the standard deviation of y is going to be the absolute value of b times the standard deviation of x, because b could be a negative number. And then remember, we don't add a because adding or subtracting does not change the variability at all, so we don't even include that. All right, note these results apply to both discrete and continuous random variables. Okay, so let's take a look here. X is the number of passengers on a randomly selected trip at Pete's Jeeps tours. Remember, you could have 2 to 6. Those are the probabilities of each. All right, now Pete's sister Erin runs Jeep tours in another part of the country. Now, Y is the number of passengers on Erin's adventures. Now, she has 2, 3, 4, or 5 passengers. I must not have enough for 6, so the distribution is there. Okay, so now let's say, what is the sum of X plus Y? Okay, of the number of passengers Pete and Erin will have on their tours on a randomly selected day. And then what's the difference of the number of passengers Pete and Erin will have on a randomly selected day? All right, so let's take a look. So if it's the mean, basically, you're just going to add the two means together. And yeah, if it's the standard deviation, again, the mean, if we're going to subtract, I'm sorry, if it's the mean, then we're going to subtract them. Just subtract the two standard deviations is very simply or I'm sorry, not standard deviations, but the means, going to subtract those means from one another. Okay, so yeah, Pete charges $150 per passenger, Erin charges $175 per passenger. Let C be the amount of money that Pete collects and E the amount of money that Erin collects on a randomly selected day. Now, from our earlier work, we know that the the average for Pete is $562.50, and it's easy to show that the average for Erin would be $552.50 if we went back and calculate that. So basically, we're going to find the average for the addition of both of those. Well, easy enough. Basically, just add the two together, and it's $1,105. Okay, so on average, Pete and Erin expect to collect a total of $1,105 per day on average over many randomly selected days. All right, so how about the standard deviation? Let's talk about that. Look at Pete's Jeeps. We got the standard deviation here. Erin's, we've got the standard deviation there. Okay, so what's the total number of passengers who go on Pete's and Erin's tours on a randomly chosen day? Well, we know that that's X plus Y. Okay, and so if knowing the value of X does not help us predict the value of Y, then they're independent. And since they're in different parts of the country, I think it's pretty safe to say that they're independent. I think that definitely is the case there. All right, so remember, to find the probability then of A and B, then we're going to multiply those two probabilities together if they're independent. So there's two ways to go get a total of 5 passengers. We could get 3 from Pete and 2 from Erin, or we could get 2 from Pete and 3 from Erin. So again, if we take those probabilities and multiply those together, yeah, that's what we're going to get, those two, and then we just simply add those together and get the 0.135. All right, so again, there it is. So those would be the probabilities, because we could have, if we're adding those together, we could get 4 all the way up to 11 is what we could have, because 6 and 5 gives us all those probabilities there, and it does add to 1, so it does make sense. All right, so now, once again, standard deviation, that's the variance. Remember, if it's squared, that's variance. And we have those standard deviations there. All right, so, and then if we did those from the sums, all the different sums that we had, going from 4 to 11, the standard deviation there would be 2.0775. I'm sorry, the variance would be 2.0775, and the standard deviation would be 1.441. All right, now, how is the variance of Pete's and the variance of Erin's and the variance of the sum? Well, yeah, does that seem familiar? 1.1875, 0.89. If you add those, do you get 2.0775? Yeah. Is it also true for This, no. What you have to do is you have to add those two variances together, and then take the standard deviation for that. That's for the standard deviation you have to do. So again, yeah, it's as simple as taking the two variances and adding them together. But for standard deviation, you have to add the variances, then take the square root. It's not quite as easy as just adding those together. So again, when we add two independent random variables, their variances add. Standard deviations don't. You got to add the variances and take the square root is what you got to do for that. Okay, so once again, as we kind of take a look here, if we're doing differences, okay, D is the difference. Let's take Pete's minus Aaron's. That's what we're going to do here. Yeah, because then we could have as low as -3, because we could go 2 minus 5, 2 minus 4, then go all the way up to 4, because we could go 6 minus 2. So this is all the different ones that we'd have, and basically, since they're independent, we can just multiply those probabilities together, right? So to get this one right here, 0.15 times 0.1 gives you that one there. So that's how you're getting those values. And once again, it's not a typo. It's actually the same thing we had before. So even if we take the difference of those values of those probability distributions, yeah, the variance you still add the variances together, and the standard deviations you add the variances and take the square root. Yeah, it's crazy. It actually does work the same way. So it's not a typo. That is true. So again, to find the mean of a difference of random, again, you're going to take the variances. If you simply just add those together, even though you're taking the difference here, you still add them together, and it's still the same formula for standard deviations. You're gonna add the variances together and take the square root is what you're gonna do. Crazy kooky, but it's true. And then remember, when we subtract two independent random variables, their variances do add. Actually, you'd think it would be subtraction. No, it does actually add. All right, so here we go. Let's look at this now. Pete charges $150 per passenger. Aaron charges $175. So let's C be the amount of money that Pete collects, and E is the amount of money that Aaron collects on a randomly selected day. Now, from our earlier work, it's easy to show that Pete's gonna have 163.46, and the standard deviation of Aaron's going to be 165.03. Now, we may assume that these two random variables are independent. We kind of figured that. So define D, which is C minus E. Now, again, what we'd have to do is we found that the mean of D was 20, and calculate and interpret that. Okay. So to find that standard deviation, the variance of D, we're going to find that by simply adding the variances. So we have to take the standard deviation squared. So we have to take the 163.46 squared, the 165.03 squared, add those together, and that becomes the variance of D, which is the difference of C minus E, right? Now, in order to get the standard deviation, then we would have to take the square root of that. Remember, variance is the standard deviation squared. So yeah, and that's from the mean difference of $20 that we found before. So that's how that works. Okay, so far we've kind of concentrated on developing rules and means for variances of random variables. What happens if we combine two independent normal random variables? Well, okay, so we got a couple different ones right here. If we combine those together, any sum or difference of independent normal random variables, it keeps it random. Yeah, it's still, I'm sorry, it still keeps it normal. Yeah, it still keeps it normal if we add or subtract those. So the mean and the standard deviation can be found using the appropriate rules for means and standard deviation. Same thing that we just did before. But it still continues to work. So let's see this. Okay, so the diameter, C, of the top of a randomly selected large drink cup at a fast food restaurant follows a normal distribution. The mean's 3.96 inches. Standard deviation of 1/100th of an inch. Now the diameter of a randomly selected large lid at this restaurant allows a normal distribution with a mean of 3.98 inches and standard deviation of 0.02, 200ths of an inch. Now assume that L and C are independent random variables. Let the random variable D be the difference of L minus C between the lid's diameter and the cup's diameter. So describe this distribution. Well, it's going to stay normal, right? And then the center, we just subtract the means. So that's going to be 0.02. Now the variability, once again, we're going to have to take those standard deviations. We're going to have to square them both to get the variance. and then add those together, take the square root to get the standard deviation of that difference. Okay, so by taking the 0.02 squared plus the 0.01 squared, add them together, take square root, we get 0.0224. That's the standard deviation of that d, which is the difference, right? Okay, all right, so now we want to get into for a lid to fit on a cup, the value of L has to be bigger than the value of C, but not by more than 0.06 inches. Find the probability that the randomly selected lid will fit on a randomly selected cup. This is a little tricky. So here's what we're going to do. We're going to take, okay, we could have a difference of 0, right? That would be as if it's exactly the same. We're going to subtract that standard deviation of 0.02, or the mean, I'm sorry, 0.02. And then we're going to divide it by the standard deviation of 0.0224, which gives us a z-score of negative 0.89. Okay, now this z-score that we have here, we're going to go, it could be as much as 0.06, but we're going to subtract the average 0.02 divided by the standard deviation. That gives us a z-score of 1.79. Now if we find those percentiles for 1.79 and for negative 0.89, there we go, that's going to give us that 0.7766. Okay, and you can use the calculator to find that as well. Nice little picture over here of what we're actually finding. We're finding the area here, and that's what those z-scores, those standardized tables, that table A, tells us that we have a 77.66% chance that we're going to find a lid that fits. That's kind of what we're looking at as we're looking in there. So again, if we put that in there, that's the chance that we're going to find a fit. So kind of tricky. Got to remember those z-scores again. Get some more practice with that. Remember, z is actual minus the mean divided by the standard deviation. That gives us that z-score, and then we have to convert that to a percentile using that table A, or use the calculator as well. All right, so again, remember after the section, we should be able to talk about the adding and subtracting of a constant, multiplying, dividing, how it affects, remember, and then calculate the mean and standard deviation of a sum or difference of random variables, and then find probabilities involving the sum or differences of independent normal random variables. So some tricky questions there. The exercises, you got to do these. You got to get that practice on these to really hit them home. So I encourage you to really work on those, ask questions, check, and when things aren't making sense, make sure to ask. But this is very valuable. All right, so that takes care of section 6.2. Until next time, I'm Mr. Boone.